Okay, so in this example, we're going to look at a specific types of intermolecular forces and of covalent bonding. So we're going to look at dative covalent bonding and induced dipoles. Okay, so in the dative covalent bonding, a dative covalent bond is one where both of the electrons have come from one donor atom. So, for example, in the ammonium NH4 ion, or to be honest, NH4 1+ ion, okay, both of the electrons on that bond come from the central nitrogen. Okay, so the hydrogen we're shown in green. In the first bond, I have one green and one red. Second bond, again, I have one green and one red. Third bond, again, one green and one red. These are normal covalent bonds. Okay. In my fourth bond, I have the coordinate bond. It's also called a dative covalent bond, where both of my electrons have come from one central atom. Okay, so it happens when I react ammonia with a source of H+, so acid-base reaction. So we also have the differences between an instantaneous dipole and an induced dipole. So instantaneous dipoles will happen when there is an even distribution of the electrons in the bond. So, for example, in a chlorine molecule. It can also happen in a bond where there is difference in electronegativity, but not sufficient to make the bond polar. So, for example, in the carbon-hydrogen bond. And it's when at one point the distribution of the cloud is exactly spherical. So there's an equal distribution across the bond. Okay, obviously in that example the electrons are less likely to be away from the bond than they are in the bond. So that would be my bond, which is why this section of the electron cloud is going to be bigger, and this section of the electron cloud is going to be smaller, because they're less likely to be there at any one period of time. Okay, and it's when that cloud gets distorted and one side of the cloud gets a larger proportion of the electrons, then the other side of the cloud gets a smaller proportion of the electrons. Okay, and obviously within chlorine molecules then, the next chlorine molecule is going to set up delta negative, so to get an intermolecular force of attraction, which we call a van der Waals force of attraction between the chlorine molecules. And then the next one's going to layer up with opposite forces, and so on and so on and so on. Okay, and an induced dipole is one where we can look at a completely non-polar molecule like oxygen. Okay, and the oxygen can go next to a polar molecule like water. Okay, so that delta negative charge forces the distribution on the oxygen to be disturbed, okay, because of electron repulsion. So we've got induced dipoles which happen from a polar molecule impacting the electron cloud in an adjacent molecule, and we've got instantaneous dipoles happening in a non-polar molecule where the electrons are distributed unevenly around the molecule at any one period of time.